In this section, we're going to learn about dividing polynomials. We will be dividing polynomials frequently when we start looking at some more difficult or intractable polynomials that we need to factor. Well, the first method we're going to look at is something you are familiar with already. It's called long division of polynomials. Now, we're going to divide this polynomial, which is a quadratic, by this polynomial, which is a first-degree polynomial, x plus 9. Now, yes, you probably already recognize that this is one you could probably factor in your heads, so you don't need to go through the long division, but we're trying to learn the long division process. So, I'm going to write it just like I would any long division problem. X plus 9 going into x squared plus 14x plus 45. So the method is, what I'd like to do is multiply this x plus 9 by something that I can put right underneath, and then when I subtract it, I want to get rid of this first term, the x squared term. So I'm really looking at the first term of this and the first term of this, the divisor, and the dividend. So if I multiply this by x, I would get x squared plus 9x. And the x squared would cancel out here. So that's what I want to multiply by. So I'm simply going to put x right there. And then x times x plus 9 is x squared plus 9x. And now we're just going to subtract. This cancels out. 14x minus 9x gives us 5x. 45 minus 0 just gives us plus 45. And then the next thing we want to do is cancel this one out. So I want to have 5x underneath here, so when I subtract, I get 0. So what would I have to multiply this by? We just look at the x. X times 5. So I'm going to put a plus 5 up there. And 5 times x plus 9 gives me that. Remainder 0. So we just found out that x squared plus 14x plus 45 divided by x plus 9 gives us x plus 5. So we could write this as, actually, maybe I don't know, x plus 5. Good enough. When we divide this polynomial by this one, we get this. Now let's do it with a little tougher one. If I'm not mistaken, we'll get a remainder out of this one. So use long division to divide this polynomial by this polynomial. Now notice this one is not written in standard form. We don't have descending exponents. So we need to do it. We need to write it correctly when we do the division. But my divisor is 3x squared minus 2x. We want to know how many times that goes into this polynomial. Okay, so the first, this is a degree 4 polynomial. That's the first term. It's got the largest exponent for the x. So 6x to the 4th. And then I've got a 5x cubed. And notice there's no x squared. Just for convenience, I'm going to leave a little space here as if it were plus 0x squared. I could write 0x squared if I wanted to, but I think I'll just leave it blank. And then put plus 3x, and then minus 5. So we got that one. Yeah, we got all the terms. And now let's do the same thing we did. Well, I want to have a 6x to the 4th right here. So what do I have to multiply this first term of the divisor by in order to get 6x to the 4th? Well, I'd need to double the 3, and I'd need to multiply the x squared by x squared to get x to the 4th. So it's going to be 2x squared. And I'll go ahead and put it, I'll write it here. It's not that important about where I place this, as long as we keep them going in the correct order. All right, so 3x squared times 2x squared is 6x to the 4th minus 2x times 2x squared would be minus 4x to the third. Now be careful here, because we're subtracting. Obviously on the left, that gives us a 0. We're subtracting a positive from a positive. Well, in the second one, we get 5x cubed minus negative 4x cubed. So we have to add the 4x cubed. 5x cubed plus 4x cubed gives me 9x cubed. Okay, and then we can bring down the next term, if we like. The plus 3x may not be necessary, but it won't hurt anything. And I could even bring down the next, the minus 5 if I wanted to. But here's the one that we want to cancel out. So what do I have to multiply the 3x squared by to get 9x to the third? Well, the 3 times a 3 and an x times an x would take care of it. So 3x. So plus 3x. So I get 9x cubed, and then what's 3x times negative 2x? Negative 6x squared. Okay, so that was our goal, canceling that out. Now be careful here. There's really a 0 here, a 0x squared, minus negative 6x squared, which gives us 6x squared. And then I can bring down this 3x plus 3x. Now I want to cancel out the 6x squared. So 3x squared times 2. So I'll put a plus 2, and that would give me a 6x squared minus 4x. The 6x squareds cancel. 3x minus a negative 4x is 3x plus 4x for 7x. And now I can bring down this negative 5 or minus 5. And we're done. Notice this has an x squared. So far this is our remainder right here, and it's only 7x. So this won't go into this, so this will be our remainder. But how do we write a remainder usually? We could write that this original polynomial divided by 3x squared minus 2x is 2x squared plus 3x plus 2 with a remainder of 7x minus 5. But a better way to write this is to say plus 7x minus 5 divided by this divisor over 3x squared minus 2x. Okay, so this what I just wrote here, that came from this remainder. And just as a reminder, if it's been a long time since you've done long division, let's just say we had 81 over 10, something like that. Well, how many times does 10 go into 81? 8 times. And what's the remainder? It would have a remainder of 1. But how do we write that? We write it as 1 over 10. That's all we did. We put the remainder over the divisor. So that has nothing to do with this problem, so I'll just scratch it out. So one more time, we've got the solution being, and I could have rewritten this in a better form if I wanted to on the numerator, but this is exactly what we were given. We divide by 3x squared minus 2x. We get 2x squared plus 3x plus 2 plus 7x minus 5 over 3x squared minus 2x. This division problem, the quotient, is exactly equal to this.